Hello guys, welcome back to my YouTube channel. Today we will be taking a look at how to create software that sucks less. So basically we'll be exploring the suckless philosophy. Uh, I'll have a link of this in the description. So basically suckless is the organization that is the creator of software like DWM, ST, um, D menu, etc. And That development is very minimal. Like all of the softwares are very minimal, and that kind of is what their philosophy talks about here in the manifest. So basically, what they're saying is that most developers think that the more lines of code there is, the more quality that code has, which is not true. And also, the more complex code they write, the better programmer they are, which is again not true. So what my understanding of the suckless philosophy is that it is an extension of the Unix philosophy, which so like the Unix philosophy itself basically tells you to create software does one thing, but it does that one thing really well. And then basically you kind of like create kind of like an ecosystem with those individual softwares that are good at what they're supposed to do. So that is how the idea of pipes came into picture. So basically an ideal software according to the Unix philosophy should just do one thing. So say take echo for example, it just prints whatever you want to in the terminal. It does one thing, it does that one thing very well. And there is another command that you can use to cat out the contents of something like the xinitrc. So the cat command basically prints out the what do we say, yeah, any file that you give it. So the cat command will basically just print out the contents of any file that you pass into it. Now like I mentioned, the ideal Unix philosophy, you would be able to do something like, for example, if I want to echo my shell, which should be easy search, yeah, and I just want to append it to the xinitrc, I should be able to do something like this. And now if I cat it out, you can see that it's been appended here. So basically what the Unix philosophy tells is that one program should do one thing, it should do that one thing well, but it should use text streams as like a universal communication tool with other softwares, and that's how it should communicate. The suckless philosophy is an extension of that philosophy, wherein they say that any code that is not absolutely needed is bloat. So basically, suckless aims to create software that sucks less by reducing the complexity, or in other words, reducing the bloat of a software. So now, how do you create software that sucks less? So here I have a project. It's a very simple C program that basically uses k-means clustering to get or to extract colors from an image. I'll show you how it works. So currently I have it installed in my system. You give it an image path, and there is a bunch of optional options that you can pass in. So yep, I'll just show you something what it does right now. I'll open another terminal and I'll run it against my wallpaper. So hopefully it'll take some time. And like you can see, the default is number of colors in the palette. The default is 5, so it gives me 5 colors here. And if I just open it in a random file just to see the highlights, you can see the colors have been extracted here. So now we won't be discussing about if this is a good software or if it's efficient or not, because you guys can figure that out on your own, like creating efficient software. What I am here to talk about is how to make sure that your software is in line with a Unix or the suckless philosophy. So now in my code, I'll basically just make it more in line with my philosophy, or with the suckless philosophy. You can see there's this option called output, right, where you can output your colors to a file. Or you can output the palette to a file. So if I run that again on my this thing, on my wallpaper, and I give the output file to be, colors.sh. It'll take some time, and it'll say palette is written to colors.sh, and as you can see, I can get the colors here. But I could do something similar. I'll just remove colors.sh so we don't have anything here. I could do something similar by just running something like this, and then redirecting its contents to colors.sh. Right, and now if I open colors.sh, I have this. So basically I have introduced, or rather not introduced, I have some bloat in my software that I can remove, and removing that basically also kind of forces my software to follow the Unix philosophy, wherein it's doing just what it's supposed to do, not doing something more than it's supposed to do. Like, it's not supposed to save a file, it's just supposed to generate colors. That's what it's doing. And it can also leverage other software, because it deals in text streams, right? It's outputting the colors to standard output, which is a text stream, so it can be integrated with other GNU slash Linux utils, and that's how I was able to redirect the contents to a file. So I'll just remove that from my print statement. And what else? Yeah, I just need to clean up my this thing. So the first line, this thing, generated palette, I don't think that's necessary. And for each color, I can just directly print the color. Oops. Okay, yeah. I can directly print the color and like the hex value without having to print color one colon whatever. So now if I do make clean, and if I do /c, or rather let me just install it, sudo make clean install, I'll put in my password and I'll build here. So now if I run it standalone, the output option is gone. I'm not able to use that, but I can now, if I run it normally, I can get the output in my standard output, and similarly I can just redirect it to colors.sh, and if I cat out colors.sh, you can see we have the colors. I'll just remove that. And also I'll just show you other features. You can check out this particular project on GitHub. I'll also have the link in description for that. You can do multiple stuffs, like you can pass your image and just have like, you can give the number of colors. So like, say for example, I just want 3 colors to be generated. I can have that. I want 10 colors to be generated. Can also have that. I want 3 colors to be generated, but I want verbose output. So I'll show you how the k-means clustering algorithm is working. Iteration 1, updated centroids, iteration 2, blah blah blah. It does that till it gets 10 iterations, because ideally you'll get the perfect centroids there, and then it just prints your centroids, which are your colors, which have been extracted. So yep, that was it. Hopefully you guys also create software that sucks less, and if you guys have anything to discuss, any questions, anything you like to correct me on, or just share with others, feel free to comment down below. Thank you guys for watching. Bye bye.